All right, let me back this up a little bit so you guys can see the whole thing. All right, so here's what we're doing. Like I said, we're going to focus on adding, subtracting, and multiplying polynomials. So with yesterday or Friday, we defined what a polynomial is. And so today we're going to actually start working with those. So we're going to do some operations with them. So add, subtract, multiply. And then tomorrow, like I said, we'll get into actually doing the division of them, which is a little trickier. The first two, adding and subtracting, that's actually pretty easy. You guys have done a lot, or you did a lot in Algebra 1 as well with combining like terms together, that sort of thing. Well, really adding and subtracting polynomials, that's all you're doing, is making sure that you put the things that are like together. Okay? So, I'll give you a quick addition example here. So let's say we want to add x to the third minus 2x squared plus 4x minus 5. And we're going to add to that x to the fourth plus 3x to the third minus x plus 7. Okay, and usually you'll see it written kind of like that, where you get both polynomials in parentheses. Okay, and so it's just a matter of going through and double checking what things are like terms and what things are not. Okay, and some of us, you can just scan it and, oh yeah, boom, boom, those go together, put them together. Oh yeah, boom, boom, those go together, put them together. And for others, maybe it's a little bit more difficult to see. And so anything that you can do to help pick them out is good. So what I'll sometimes do is, like, here's an x to the third. And I'm going to underline that one real dark. And find another x to the third. Maybe underline that one real dark. So I know those go together. Here's an x squared, but there's no other x squared to match with that, so I'm not going to do anything with that. Here's an x and an x. Okay, so maybe you do like a little wavy line under that one and a wavy line under that one. I know those two go together. And then maybe just a little underline on those two. Okay, the -5 and the 7, those go together. So it becomes really obvious which things are like terms, and then it's a little easier just to pull it together. But essentially, all you're doing is adding the things that are like. Okay? So the highest degree that I see in this thing from both polynomials is 4, right? X to the fourth has nothing else that goes with it, so that remains just x to the fourth then. Okay? And then the next one would be x to the third. Well, on that one I've got a couple. I've got x to the third and I've got 3x to the third. Combine my like terms together, and how many do I have? 4x to the third. And then x squared, -2x squared, but there's no x squared over here, so it's still just -2x squared. And then my x's, I got a 4x and a -x plus 3x. And then I got a -5 and a 7 plus 2. Boom, done. Easy, right? Just like term business, put them together. Now, subtraction, I almost guarantee I will catch someone on their test with subtraction. It's easy, but if you're not careful with it, it's easy to make a mistake. Okay, what people tend to do, and this happened with the complex number stuff too. We had on our last test, back in chapter 2, we were talking about complex numbers, and part of what you had to do was add complex numbers, subtract complex numbers, and people always want to take a subtraction problem and then just make it an addition problem. They aren't careful and don't check to see, oh yeah, that's actually a little minus sign right there, that's not a plus sign. So let's try this for a second. So let's do that polynomial minus 2x to the third plus x. All right, so let's try those two polynomials. X squared plus 4x to the fifth, that's the fifth, minus 3x to the third plus 5 minus 2x to the third plus x minus 2x to the fifth. Okay, so First thing that I would do when you're doing this is, if you don't like the fact that it's a subtraction problem, okay, so make it an addition problem then. Okay? But if you're going to make it an addition problem, you need to make sure that everything in this second polynomial changes sign then. Because you're subtracting every single one of these terms. Okay? So every single one of these needs to be made negative because you're subtracting them away. So I would just do this then. X squared plus 4x to the 5th minus 3x to the 3rd plus 5. Don't change anything with that first one. And then plus negative 2x to the 3rd minus x plus 2x to the 5th. And now it's just as easy as the first one that we did. Okay? As long as you take that first step, you can make it an easy problem. Okay? And now it's just a matter of matching those things again. Okay? So x squared, there's no other x squared to match. Let's see, 4x to the 5th, 2x to the 5th. Here's an x to the 3rd, there's an x to the 3rd, and nothing else matches. Okay, so the highest power I'm seeing is to the 5th. So I got 4x to the 5th plus another 2x to the 5th, so 6x to the 5th. The next highest power I'm seeing, x to the 3rd, negative 3, negative 2, that's negative 5. And then the next highest power, there's an x squared, and then minus x, and there's a plus 5. Got it. Okay, so does that make sense? Yeah. Just switching it over. Okay? I don't want the addition and subtraction ones to be any kind of a stress for you guys whatsoever. They don't need to be. Okay? The addition, you're combining like terms. Subtraction, switch the signs on the second one, and then it's exactly the same thing. Okay? You can always turn a subtraction problem into an addition problem, and then you're good to go. Okay? So I want to kind of move on because the majority of what we need to talk about today is multiplication. Because multiplication involves there's a lot more stuff going on with that. Okay? So wanted to make sure these were not a problem before we went on to that. So with the multiplication of polynomials, we need to review some rules of multiplying just one term with one term. Okay? And see how much of this you guys remember. So let's just try multiplying 3x squared and 5x to the 3rd. Okay? So what do we remember about the rules that we have to follow when we're multiplying two monomials like that? 3x squared and 5x to the 3rd. That's always the question. Do you add the exponents or do you multiply the exponents together? You add them together. Right. You multiply coefficients, but you add the exponents. So this would be 15x to the 5th. Okay? If you can keep those little rules straight, most of the multiplication work you're going to do shouldn't be an issue. Okay? Yeah. The reason that you add them, are you kidding or not?
No.
No. Okay, well then let me explain. Oh, I should have probably figured that. An exponent tells you how many of something you have when you're multiplying. So this problem, I could technically rewrite as 3 times x times 5 times x times x times x. Okay? So if I rearrange this thing, it's 3 times 5 times x times x times x times x times x. Right? Okay, so the 3 times 5 is 15. And then x times x times x times x times x. How many of these do I have? 5 of them, right? So it's x to the 5th. So when you're adding those, you're really counting how many you have when you had 2 and you had 3, but now I'm putting them all together. I got 5 of them now, so it's x to the 5th. That's why that works. So, okay, so if we're, like I said, if we're good with that rule, then we can get into some more, I call them interesting, but you might just call them challenging. Some more interesting / challenging questions. So like, if we had something like that, 2x squared minus 3x to the 4th plus 5 times x squared minus 3x. Okay. When we multiply these together, we have to make sure that everything is multiplied to everything. It's kind of like when you FOIL, but even more so. Okay? When you FOIL, you have a binomial times a binomial. Two-termed thing times a two-termed thing. This example, I have a trinomial times a binomial. I have a three-termed polynomial times a two-termed polynomial. Okay? So, remember when we did those little, like, when we FOILed, we did little arches to kind of make sure everything was multiplying to everything? Well, same kind of idea. Okay? So, 2x squared needs to multiply with x squared. So I'm going to just start writing them out here. So again, we're following these kinds of rules that we talked about up here. So what is 2x squared times x squared? 2x to the 4th. Okay, and then 2x squared needs to also multiply with negative 3x. So what would that be? Negative 6x to the 3rd. Okay, and then I got to go to the next one and make sure that this term gets multiplied with both from the one over here. So negative 3x to the 4th times x squared. Yep, negative 3x to the 6th, and then this one needs to get multiplied with negative 3x. So plus 9 x to the 5th. And then the 5 needs to go to both. So 5x squared. And then minus 15x. Okay, so it can start to look really long and complicated, but really it's not necessarily difficult. It's just there's a lot there. Okay, when you multiply polynomials, inevitably we end up with these really long ones when we're done. And there might be some like terms in there too that we can then shrink it up a little bit, but it's probably still going to end up a big long thing. So take a look at the powers on there. Do we have any like terms in there? No, we don't on this one. So we do want to. We got to put it in standard form though, just to kind of keep it looking the same as other polynomials we've worked with. So the highest power, what do we got? 6, right? Okay. So negative 3x to the 6th would come first, plus 9x to the 5th, then 2x to the 4th, minus 6x to the 3rd, plus 5x squared, minus 15x. So that would be our polynomial. So what do you think, I mean, with something like this, what do you think is the biggest issue that students have with this? It could be either they miss one of the multiplications that they need to do. Yep, that happens a lot. Don't add the exponents? Actually, that one's not so bad.
I was going to say, like, all they might do is, like, the 2x squared times the x squared, just multiplying like terms and leaving out all the others.
Right, yep, that happens a lot too. So that's usually some kind of omission somewhere. They forget to do a multiplication somewhere. And it really boils down to being careful. If you're trying to get through it fast, you're going to make a mistake. Okay. He doesn't do that necessarily. All right. That's the biggest issue I've seen with this in the past is anybody that's trying to rush through this and just get it done, just get it done, just get it done. I don't want to have homework tonight. I just want to get it done. They inevitably are the ones that make the mistakes. People that are careful about it and take their time and make sure it's right, they, well, get it right. So it doesn't need to be anything really difficult, like I said, but you just have to be really, really careful with it. No? So we're going to do some more types of multiplying. Next we're going to multiply 3 polynomials together. Talk about how you do that. And then I'm going to show you some special products. So some multiplying that, yeah, you could do it the long way, like we're going to do here. But with certain ones, there's some shortcuts you could take. So it's not so bad. But let's look at 3 of them here real quick. Okay, and I'll be nice. I'll make them each a binomial, so it's not going to be crazy. Okay. So essentially, we're multiplying 3 things together. Think about, for a minute, how you would multiply 3 numbers together. Let's say I asked you to do 3 times 5 times 2. What's your strategy for multiplying 3 numbers together in your head? Right, so what you would do, you probably wouldn't write this down, but what you would do is, okay, 3 times 5 is 15, and then I need to do 15 times 2, so 15 times 2 is 30. So the answer to that problem would be 30. Okay, so when you do this, it's the same idea. Don't try to do all 3 at the same time. Good Lord, that's going to get crazy. Just take 2 of them, multiply those 2 together, whichever 2 you want. It doesn't really technically matter, but pick 2, multiply those 2 together, and then take the answer from that, just like you did the 15, and multiply that with whatever you have left over. Okay? So let's just pick the first 2 then. Okay? Just multiply with those 2. So x times x squared, x to the third, x times negative 3, negative 3x, 5 times x squared, plus 5x squared, 5 times negative 3, minus 15. Okay, that's the first one. We can put that in parentheses here. And you don't even need to rearrange that or whatever. And if there's some like terms, go ahead. Do the like term thing, because that's going to save yourself some time. But if there's no like terms to combine, you don't need to worry about rearranging it, because you're just going to go through and start multiplying things, and it might screw around with the order anyway. But the point is, you take that answer then and multiply it with the other polynomial you still have. So x plus x squared there. Okay? And so, yeah, this thing's going to get really long, but we can still do it. So x to the third times x, x to the fourth, x to the third times x squared, x to the fifth, negative 3x times x, negative 3x squared, negative 3x times x squared, negative 3x to the third, 5x squared times x, 5x to the third, 5x squared times x squared, 5x to the fourth, negative 15 times x, and negative 15 times x squared. Okay. Do you guys see how I was being kind of methodical about that? Did you guys catch what I was doing, what my process was when I was multiplying to be sure that I didn't miss one? Look at how I multiplied those. Look at the order that I multiplied things in. Do you see how I made it so I was sure I didn't miss anything? I just went right down the line of this first one. X to the third, it's got to hit both of these. Did both of them. Boom, boom. Those 2. Negative 3x. Boom, boom. Did it with both of them. Got those. 5x squared with both of them. Boom, boom. Got those. Negative 15 with both of them. Boom, boom. So I got 4 terms in this one. I got 2 terms in this one. How many terms should I have in my answer then? You can combine them, but before I combine like terms, just as a check to myself to make sure I didn't miss one, how many should I have? 8, right? That's an easy way to check to make sure that you didn't miss something along the way. Okay? I got 4 in this one. I got 2 in that one. If everything in this one is matching with everything in that one, I should have 8 terms when I'm all done. And if I count here, 1, 2, 3, 4, 5, 6, 7, 8, yeah, I do. And then after you've done your quick check, all right, now let's combine like terms, see what this thing actually is when we're all done. So our highest power is x to the 5th. All right, so that's coming first. Then I got an x to the 4th, 5x to the 4th. So we got 6x to the 4th. And then x to the fifth, just this one, right? Oh, I already did that one. We're down to third, so we got negative 3 and 5. So 2x to the third. And then negative 3x squared, negative 15x squared. Yep. And we got the minus 15x. So that would be my final polynomial after I've multiplied all that stuff together. Okay? So all the steps along the way, nothing tricky there. It's just a matter of being careful to make sure that you've gotten everything. Okay? So, all right, so some special product stuff. Hopefully this will help you to kind of save yourself some grief. So we're going to do a little bit of multiplication here with some of these, just to kind of discover a little bit how these things work. Okay, take a second, multiply those together. And maybe you recognize this one already, I don't know, but try that multiplication and see what you get, because this is one of our special ones. If you combine two like terms that are in the middle, you should end up with that, right? Should have been a minus 2x and a plus 2x in the middle. And both of those will cancel each other off, so you end up with just simply x squared minus 4. Okay? So, let me give you another one. See if you can tell me what the answer of this one is just by looking at it. See if you've caught on to what the pattern might be. What do you suppose that's going to be? And if I were to do x plus 4 and x minus 4, x squared minus 16. It is, yeah. It's always the square of whatever these two numbers. Well, basically these two numbers multiplied together give you that one. The middle terms are going to keep canceling each other out with these. As long as this is a plus and this is a minus, that's always going to be the case. So in general, plus a, whatever a is, and x minus a, as long as these are opposite signs and these are the same number, you're always going to have x squared minus a squared. That's one of your special products. If you see that, you don't necessarily have to do that all the way by hand. Now, if you want to, there's no problem with that, but there's a shortcut, right? There's a pattern there where that always works. Okay. What if the signs weren't different? What if they were the same? There's a pattern with that too. So don't just try to guess at it. Actually multiply that out. Okay? It's probably not what you would expect, but multiply that thing all the way out and see what you get. We'll do x plus 2 and x plus 2. So right there. And once you have that one, do that one as well. So x plus 2 and x plus 2, and then also x plus 3 and x plus 3. Comes out looking a little different than the last ones did. You got it. Should have had those two, right? You guys remember when we completed the square? Do you see how these are perfect squares? Technically? X plus 2 times x plus 2 is actually just x plus 2 squared. It's a perfect square. x plus 3 times x plus 3 is x plus 3 squared. So remember how we said take the middle term, divide it by 2, and square it? That gives you the last one. What's half of 4? 2. 2 squared? 4. What's half of 6? 3. 3 squared? 9. So that pattern always happens there with those, too. It's a square pattern. So with these, in general, if you have something x plus a times x plus a, so if both the signs are the same with the same number, you end up with x squared. Okay, now this, look at this. You had 2, now it's 4. You had 3, now it's 6. You're timesing it by 2, right? So it's plus 2a x. And then you had a 2, you got a 4. You had a 3, you got a 9. What's on the end? What's that pattern? A squared. Good. So we've got that kind of pattern if they happen to be the same. Okay. Now if I had something that was, let's say they were both minus. Okay, I'm just going to write the pattern for this one. The only thing that changes is you're going to have minus 2ax in the middle. Still plus on the end. Anybody tell me why the middle term changes sign, but the last one doesn't? Yeah, Jason. Yeah, he's got his hand in the air. Go for it.
Negative plus a negative is just more negatives, and then the negative times a negative is positive.
Right. Right, because essentially that middle term is you're adding the two things together. So that's just more negative. And then a negative times a negative is still positive, so it's still plus a squared at the end. Okay? So if they happen to both be negative, that's really the only difference, though. It's the same basic pattern, it's just the negative stays in the middle there. Okay? I won't do any examples with these two because it'll just take too long. But what if you have something that is multiplied by itself 3 times? There's a pattern with this too. It ends up being x to the third and the front. Does that make sense why it's x to the third? Because you'd end up with an x times an x times an x at some point, right? So you have x to the third, and then it is... You get plus 3... Oops, that would be... Sorry, 3a x squared. Looks like that. It's not as bad as you might think. Okay, just look at the there's a couple different patterns. There's a pattern in the coefficients, and there's a pattern with the x's and the a's. Okay, and neither one is terribly crazy. Okay, so look at the pattern in the coefficients. You have a 1, 3, 3, 1. That's always the same. 1, 3, 3, 1. Okay. Now look at the x's. What do you notice about the x's as you go through each term? Just goes down 1 each time. X to the third, x squared, x, nothing. And then look at the a's. What happens with the a's? Nothing, a squared, a to the third. Do you see that pattern too? Okay. A's are going up, x's are going down. 1, 3, 3, 1. Okay. So that works with the plus a. There's also a pattern when they're all minus, which I'll show you next. Then we'll practice a few of these where we can try to use the little patterns here instead. Okay? If you don't like trying to follow the patterns, multiply them all out. There's nothing wrong with that. You can still do that. Okay? These are not be-all, end-all little formulas here. They're supposed to be there to help you get through it more quickly. But if it's more confusing, then don't worry about it. Just do the multiplication the long way. Okay? So, That's if they're all plus. And then, like I said, there's another one if they're all minus. And so this one, x to the third minus 3ax squared plus 3a squared x minus a to the third. How do we get the what? 3ax squared? Well, what ends up happening is, remember how up here we ended up with a 2? Because you would have a 2x and a 2x, or you'd have an ax and an ax in the middle here, if you multiplied this all out. Do you see that? You'd have to multiply the a times the x, and then you'd have to multiply this a with this x. So you'd have 2 of those a times x's in there. So that's where this comes from. Same kind of idea down here. You end up with an a times an x, but you have to do it 3 times because there's 3 of them. So that's where these 3's pop up, because it goes 3 of them for each different way that you do it. But in any event. So let's try it. All right. So keep these somewhere where you can see them. And let's do all right, let's do x plus 5 squared and x plus 5 to the third and see if we can use the little shortcut method to do it. Okay, so x plus 5 squared is really x plus 5 times x plus 5, right? Okay, so that's going to be one of the squared ones. So if we go back to here, okay, we're going to follow this pattern. What's the a that we're using in this example I just made? 5, right? Okay, so I'm going to follow this little pattern here, but everywhere I see an a, I'm going to put in a 5 instead. Okay? So it would look like that. X squared plus 2 times 5x plus 5 squared. So this would be x squared plus 10x plus 25. Okay. Now that one, again, if you wanted to just multiply it all together, you can get to here too, right? X times x is x squared. 5 times x, x times 5, that's where the 10x comes from, and then 5 times 5 gives you 25. You could easily get to the answer just multiplying it all the way out by hand, and that's fine. This one, you'd be at it for a little while, but it's doable. X plus 5 times x plus 5 times x plus 5 is what we have there. So that's one of the ones down here. Okay, trying to follow this pattern. So again, a is 5, so I'm going to take this, I'm going to copy this down, but everywhere in this little formula there's an a, I'm going to use a 5 instead. Okay, so for that one, it's going to start off x to the third, and then plus 3 times 5 x squared plus 3 times 5 squared x plus 5 to the third. So then with that one, we end up with x to the third plus 15x squared. 5 squared is 25 times 3, so that's 75x plus 5 to the third. 125. Good, yeah. 5 times 5 is 25. 25 times 5 is 125. And if you want to use your calculator to help you with some of the bigger multiplications, not a big deal. But that would be that one all multiplied out. Okay? So that's how you can find little formulas to get at to some of those special products a little bit more quickly. Some other ones that kind of follow that same pattern, a little different. We had something like this. All right, so I'm going to stop using x, and I'm going to change things just a little bit, but they should still look familiar, though. Okay, put your heads up, guys. Up. Write something down. Write some more down. Write this down. Yeah, now you're doing this one. Okay, so look back to all of these that we wrote down, and this example, 4n plus 5, 4n minus 5, which of these does it look like? The first one. Has that same kind of look to it, right? But instead of using x and a in both of them, I'm using 4n and 5. But it's the same idea, okay? It's still going to be the first thing squared minus the second thing squared, okay? So let's see if we can apply that idea to this thing, okay? So instead of just x, now I have 4n. So it's going to be, yeah, you're one step ahead of me, but 4n squared minus 5 squared, right? Instead of x, we're just using 4n, but it still follows that same kind of pattern. So it's 16n squared minus 25. Okay? Yeah?
How does it get from 4n to 16n squared?
Because I'm squaring 4n.
Right, so how come you don't, how come you keep the squared then?
Keep the squared on n.
Like what? How is it 10 squared?
Right, because 4n squared is 4n times 4n, right? So it's...
I don't know, I just heard them as like one number.
Oh, okay. Yep, I gotcha. Try another one. How about... So what if I had 3t plus m and 3t plus m? So look at that. Let's go back to this stuff. Which one does that look like? It's not the top again, actually. Second one, right? Because they're both plus this time, right? So it's going to fall into this little pattern right here. Okay? So x squared plus 2ax plus a squared. Okay? But instead of x, what am I using this time? 3t. Okay? And instead of a, what am I using this time? M. So follow the same little pattern, but you're going to use the 3t and the m instead. Okay? It is, but it works. So for that one, we're going to have 3t squared plus 2m times 3t plus, and then it had a squared, so in this case it would be m squared. So we got to kind of simplify this up just a little bit. So 3t squared would be 9t squared, and then the middle would be plus 6mt, and then we got just m squared there. And so that would be it, because you can't put those together anymore. Okay, now, with something like this, trying to follow that pattern, that's a little tricky, okay? Probably would have been easier just to multiply this one out, right? Let's do that for a second. Let's try it that way, and so you can decide what you like better. But for some of these, yeah, trying to find a little pattern can get really confusing. So we end up with 3t times 3t. That's 9t squared. 3t times m is 3mt. And then we get m times 3t, so another 3mt. And then m times m is m squared. And then these two, do you see how they're like terms now? 3mt, 3mt. So we get 9t squared plus 6mt plus m squared. So that works a lot better then. Okay. Now, if you get to some powers that are really, really big, like we've only been doing like to the second power, to the third power, and for those, multiplying it all the way out might be less confusing, might be even less work sometimes, like this one was. But you get to like a fourth power, a fifth power. Okay, think about doing something like this. What if I had to do x plus 2 to the fifth? It looks easy, but you know what you're actually doing there? You're doing x plus 2 times x plus 2 times x plus 2 times x plus 2 times x plus 2. It's a lot of multiplications, right? So doing that one by hand, probably not. Okay? But there's a pattern that you can use, and it relates to these patterns we were talking about over here. It's this thing called Pascal's triangle that lets us do it. Has anybody ever heard of Pascal's triangle? Yeah. Heard of it, but don't know what it is necessarily, maybe? Okay. Well, let's take a look at what that is, and then we'll be done, and we can do this one real quick, okay? So I'm going to leave some room for this problem, but I'm going to come over to the next page, and I'm going to show you Pascal's triangle and see if you remember what this is after I do it. Looks like this. See if anybody can tell me the pattern that's going on here. Maybe we'll stop at this one. Yeah, kind of. All right. Somebody tell me patterns you see in there? Any patterns you see at all? There's lots. However you want. There's no one right way. Just look at the outside of it. What do you see everywhere? Ones. Okay, there's a pattern. Anything else? Yeah, you see the 1, 2, 3, 4, 5, 6 going this way? Going that way? Okay. Mm-hmm. So what do you mean by that exactly, adding them off to the side?
Yeah, like start with the 2 and the 1.
Mm-hmm.
Right, and that adds to 3. 3 and then adds to 4.
Yeah, did you guys see that? And that's basically every number in every row works that way, right? You look above it. Look to the row above it, and look at the 2 numbers that are to either side of it in the row above it, and they add to the 1 below it. Every single one. That's how I made it. So when I was doing my last row here, I went, okay, I know it needs to start with a 1, and then 1 plus 5, 6. 5 plus 10, 15. 10 plus 10, 20. 10 plus 5, 15. 5 plus 1, 6. Okay? That's how you can build the triangle. Okay? Now, what the heck does this have to do with what we were just doing? Well, each one of these rows is a different power that you could put on a binomial. Okay? It's called a binomial expansion. All right? Remember that one pattern? Well, I can't remember who it was. I think it was Destiny that asked me about how do you get the 3s? Remember the one where it went 1, 3, 3, 1? 1, 3, 3, 1 is right there. Remember when we were squaring things? There was always a 2 in the middle. There was always 2a in the middle. 1, 2, 1. That's this row. Okay, each row corresponds to a different expansion. Okay? So like the first row would be when n is 0. So that gives you that row. The second row is a plus b to the first. The next row is a plus b squared. The next row is a plus b to the third. A plus b to the fourth. And what all these numbers represent in this triangle are all the little coefficients in front of each term when you multiply the whole thing out. Okay? So, like for that last example that we were doing, we were working on x plus 2 to the fifth. So we would be concerned with this row right here. Okay, the 1, 5, 10, 10, 5, 1. So what's going to happen is the coefficients of that x plus, what was it, 5, 2, x plus 2 to the fifth, it would go a 1, a 5, a 10, a 10, a 5, and a 1 when we had that all multiplied out. Okay? So, now there's a pattern in the coefficients, like I just said. We'd be looking at these numbers as the coefficients. But then also there's a pattern in the actual expansion to it. Okay? So, I'm going to draw another Pascal triangle right underneath this one that's going to include all the little a's and b's that go with the numbers that go on there. Okay? So a plus b to the 0, that's easy. Anything to the 0 power, we talked about that on Friday. That's what? 1. Okay. So there's that one. A plus b to the first would be just a plus b, or 1a plus 1b. See the 1, 1, 1, 1 happening in that one? The next one, a plus b squared, is 1a squared plus 2ab plus 1b squared. 1, 2, 1. Okay, keep watching. There's going to be some more patterns popping up here. So, a plus b to the third, 1a to the third, plus 3a squared b plus 3ab squared plus b to the third. Okay? See the 1, 3, 3, 1 in there? It's that next row of Pascal's triangle. And we keep going down, and look at those patterns with the a's and the b's. You guys see how the a's keep going down and the b's keep going up every time? So a plus b to the fourth is going to be 1a to the fourth plus 4a to the third b plus 6a squared b squared plus 4ab to the third plus 1b to the fourth. Okay, look in there, okay? I know there's a lot written down. I know that you see a lot of things on a page and you go, ugh. But look, okay? Actually look at it. It's not that bad. You've got, who just sighed? Stop it. 1, 4, 6, 4, 1. Boom, it's right there, okay? Look at the a's. A to the fourth, a to the third, a squared, a, no a. Look at the b's. No b, b, b squared, b to the third, b to the fourth. Okay? You can do those. You can do those patterns. So you tell me, what's the next one? Okay, let's start. Let's see if you guys can tell me what we got to have here for the fifth power. What's my first term going to be? 1a to the fifth plus what? Remember we're on this row. 5a to the fourth times b. Okay, next one. It's a to the fifth, a to the fourth, 10a to the third. What about the b? We had no b, b squared plus 10 a to the fourth b to the third, good. Just you got to let one go up and the other go down, right? Next coefficient would be 5, then what? Nope, follow the pattern. Oh, wait. I went the wrong way there. This should be a, right? A to the fifth, a to the fourth, a to the third, a squared. Now it's just 5a. Then what's the b? B to the fourth, right? And then 1 b to the fifth. So that's the line that we have for a plus b to the fifth. Well, the one we were doing was x plus 2 to the fifth. Okay? So my a is x, my b is 2. Okay? So we're just going to make little substitutions in here for this. So 1a to the fifth would just be x to the fifth. Okay, then we've got 5a to the fourth, so that's x to the fourth. My b is 2, so that times 2. And then I got 10a to the third, so x to the third, 2 squared. And then we got 10x squared, and then 2 to the third. Plus 5x, now it's b to the fourth, so 2 to the fourth. And then it's just 2 to the fifth, right? Alright, and then all the little numbers I got to kind of clean up in here, but then I'm done. So it's x to the fifth. 5 times 2 is 10. 2 squared is 4. 4 times 10, that's going to give me 40. 2 to the third is 8. 8 times 10, that's going to be 80. Uh, 2 to the fourth is 16. 16 times 5 is 50. I think 82. Hold on. Double check that. 16 times 5. It's 80. Right? So 80x, and then 2 to the fifth. That's 32. Alright, so that would be your big long expansion. Now, would it be easier to do that all out by hand? The 5x plus 2's all... borderline maybe. You go much above 5, and trust me, the triangle is going to be the easier way to go. Just is. It just is. You're welcome to try and multiply it all out by hand, but you might be at it for a while. But the triangle's there to help you, not to hurt you. So just remember that. Homework is going to be, page 170 to 172. I'm going to do 1, 2, 3 to 47, and 55 and 56. Keep in mind, the majority of this assignment is not the big old long expansions that we just finished with, okay? Most of it is the addition, subtraction, and simple multiplication. All right, there's only a handful at the end where you have to actually expand out something really, really big.